1. Introduction to Docker. 1.1. Docker versus containers versus Docker images. Docker is a commercial containerization platform and runtime that helps developers build, deploy, and run containers. It uses a client-server architecture with simple commands and automation through a single API. With Docker, developers can create containerized applications by writing a Docker file, which is essentially a recipe for building a container image. Docker then provides a set of tools to build and manage these container images, making it easier for developers to package and deploy their applications in a consistent and reproducible way. A container is a lightweight and portable executable software package that includes everything an application needs to run, including code, libraries, system tools, and settings. Containers are created from images that define the contents and configuration of the container, and they are isolated from the host operating system and other containers on the same system. This isolation is made possible by the use of virtualization and process isolation technologies, which enable containers to share the resources of a single instance of the host operating system while providing a secure and predictable environment for running applications. A Docker image is a read-only file that contains all the necessary instructions for creating a container. They are used to create and start new containers at runtime. 1.2. Importance of Docker for data scientists. Docker lets developers access these native containerization capabilities using simple commands, and automate them through a work-saving application programming interface, API. Docker offers improved and seamless container portability. Docker containers run without modification across any desktop, data center, or cloud environment. Even lighter weight and more granular updates. Multiple processes can be combined within a single container. This makes it possible to build an application that can continue running while one of its parts is taken down for an update or repair. Automated container creation. Docker can automatically build a container based on application source code. Container versioning. Docker can track versions of a container image, roll back to previous versions, and trace who built a version and how. It can even upload only the deltas between an existing version and a new one. Container reuse. Existing containers can be used as base images, essentially like templates for building new containers. Shared container libraries. Developers can access an open-source registry containing thousands of user-contributed containers.